Today I will walk you through how to do a formal two-column proof to prove that triangles are congruent. So we're proving congruent triangles. Alright. So previously we learned about 5 different ways to tell if triangles are congruent. We have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So these are the 5 tools we can use to show triangles are congruent. So I will use this right here, number 13, as an example. So our job is to prove that triangle AMC is congruent with triangle BMC. So this is a proof. Prove that triangle AMC is congruent with triangle BMC. So when you look at the picture like this, your job is to identify what information they gave us. In a two-column proof, you have 2 columns. You have the statements and the reasons. Statements are things that we can say. For example, which sides are congruent? And reason is, how do we know they're congruent? Using this example, in a proof, we always start with information they gave us. So right here, we see there's a tick mark along AC and a tick mark along BC. So that tells us that AC is congruent with BC. Our reason for that, it's given. It's something they already told us. It's there to begin with. Next thing they told us is M is a midpoint. Of AB. Again, reason we know that is it's a given. They told us that. So with this information, start thinking, which of these 5 statements could potentially help us to prove that these triangles are congruent? Which of these 5 are we using? So going off from what they told us, M is a midpoint. Right here, M is a midpoint. That means AM has to be congruent with MB. That's what midpoints do. So AM is congruent with MB. Reason for that is the definition of midpoint. So we have a side, we have another side. Looks like we'll be using one of these 4. We have done enough examples. Hopefully you can see, notice how MC right here, both triangles, the left and the right, physically share that side. They're both touching MC. So this is a third side we have. So we can say MC, the triangle on the left, the MC on the left, matches with MC, the triangle on the right. So MC is congruent to MC. We call this the reflexive property. Reflexive meaning it's the same thing. It equals, it's congruent to itself. Because they both have it. So, according to the statements we've written, we have one side, AC congruent to BC, another side, AM congruent to MB, and a third side, MC congruent to MC. We have a side, side, another side. So now we can use one of these 5s. We can now say that triangle AMC is congruent to triangle BMC, and the reason for that is the side, side, side property. So there you have it. This is a two-column proof, which is basically a way of listing out step by step how did we end up with side, side, side. Alright, let me do one more example. Alright, let's see. Let's look at number 15 for example. Are these two triangles congruent? If so, state how. So again, our job is to prove that triangle JKL is congruent with triangle MNL. Alright, here we go. So again, as with any proofs, we have our statements and our reasons. And we always start with information they gave us. Right here they told us JK is congruent with MN. The tick marks are there to begin with. JK congruent MN. That's a given. And then they also told us that JK is parallel to MN. That's another given. Now this goes back to our third unit when we talked about parallel and transversal lines. JK right here is parallel with MN. When we have two parallel lines cut by a transversal, we have angle N with angle J, are alternate interior angles. That means angle J is congruent with angle N. We know that because they are alternate interior angles. Alright. Another thing I see is in here we have vertical angles. We can also use that. This angle congruent with that angle. So that's angle KLJ is congruent with angle MLN because of vertical angles. So now we have matching sides, matching angles, another set of matching angles. So side, angle, angle, or angle, angle, side, same thing. So now we can conclude those two triangles are congruent. Triangle JKL is congruent with triangle NML by angle, angle, side. Right, real briefly, over here I wrote M and L, but let's keep in mind that the order of the letters matter. Right here, we started calling this JKL. J, the matching corresponding angle of J. J is congruent with N. Because we started with J, we have to start with N. That was my mistake. N, M, L. So there you have a two-column proof, which is basically a way of us listing out step by step what properties did we use to be able to say side, side, side. That we had one pair of sides, another pair of sides, a third pair of congruent sides. The side, side, side. Or how did we use angle, angle, side? That we had one pair of congruent angles by alternate interior angles. We have another pair of congruent angles, vertical angles, and we have one pair of congruent sides because it was given. That lets us use AAS.